Hello Rahul, how are you? How I can help you?
Sir, I would like to know about the force today. Can you please explain me in detail about the force, sir?
Yes, today I can talk about force and all information related to the force. So let us go to the classroom and talk about force in detail. Let us talk about force today. Once again, welcome you all, and let's hope we'll enjoy together and we'll enjoy our company. And I'm going to talk about the force. A railway engine moves due to applied force. Car moves due to applied force. A glider moves due to applied force. Even a cricket ball moves due to applied force. So when you apply the force, body moves from one position to another position.
Sir, when I do play the football, I push the ball, and while fighting with my friends, I pull his collar. So, can I consider pushing and pulling are the example of forces?
Yes, pushing and pulling are the example of forces because the object goes from one position to another position, while pulling also objects come from one position to another position. Thus, pushing and pulling are also example of force.
Sir, when I do apply the force on the body, some body moves faster and some body moves slower. Why do so, sir?
Consider two bodies, one is a lighter body, another is a heavier body. If you apply same amount of force on a lighter body and on a heavier body, it is general observation that lighter body moves faster compared to heavier body. That implies when you apply the force, acceleration produced in the body depends upon mass of the body. More the mass, less the acceleration, and less the mass, more the acceleration.
You mean to say that if I apply the force on a stone, heavy stone, and apply the force on a lighter like a football, then heavy stone will move with less velocity compared to the lighter ball. That means the acceleration is inversely proportional to mass, implies mass and acceleration are inversely related to each other. Is it true, sir?
Yes, you are right. Mass and acceleration are inversely related to each other. So, we make a statement acceleration inversely proportional to mass.
Sir, can you give me the exact definition of acceleration and mass relationship?
Yes, why not? If equal force F acts on different bodies, the acceleration A produced in each body is inversely proportional to the mass of that body. A is inversely proportional to m. That is, if same force acts on heavier body and on a lighter body, then lighter body will have more acceleration compared to heavier body.
Sir, it is my practical experience that if I apply more force, body moves faster. If I apply less force, body moves slower. I would like to know, is there any relationship between acceleration and the force?
Yes, why not? Let us define the relationship between acceleration and force. If the forces of different magnitude applied on the same body, the acceleration produced in the body is directly proportional to the magnitude of the force. This is what the acceleration and force are related by. This is the relation. Acceleration directly proportional to magnitude of the force. That is the relationship between the acceleration and force. Thus, acceleration directly proportional to force. This gives another relationship between acceleration and force. Now, let us summarize the things. Acceleration inversely proportional to the mass of the body. Therefore, A proportional to 1 upon m. Let us call it as a equation number 1. And the second one, if the forces of different magnitude are applied to the same body, then acceleration produced in the body directly proportional to the magnitude of the force. Therefore, A proportional to F. Let us call it as a equation 2. Now, we will combine equation 1 and 2 implies A is proportional to F upon m. We have combined the equation 1 and 2 and let us call it as a 3. From this equation we get A into m proportional to F. That is F proportional to ma. Now let us say K be the constant of proportionality. Therefore, F equals to Kma, where K is nothing but constant of proportionality. Constant of proportionality. Therefore, F equals to Kma. Now, F is equal to 1. Suppose F equals to 1 implies M has to be 1 and A has to be 1. Implies what implies? For unit force F equals to Kma. In the equation F equals to Kma, the value of K equals to 1. For unit force, the value of K equals to 1. Therefore, we get F equals to ma. This is a relationship between the force, and this is an expression for force, that is F equals to ma. Therefore, force is nothing but product of mass and acceleration.
Sir, can we write above equation in terms of vectors?
Yes, above equation can be written in terms of vector as follows. Vector F equals to m into vector A. This is a relationship, and this equation is called force equation.
Sir, you said force is a vector quantity because acceleration is a vector quantity. Sir, can you please give me one example to state that force is a vector quantity?
Suppose we apply a force on a body, then the body moves from one position to another position, from one place to another place. And also, due to applied force, the velocity of the body changes. And due to change in the velocity of the body, the momentum of the body also changes.
Sir, you said when you apply the force, momentum of the body changing. So, momentum of the body not changing suddenly, it consumes certain time. Therefore, we can define the force on the basis of changing the momentum of the body and the time consumed to change the momentum.
Yes, you are right. Change in the momentum with respect to time is nothing but basis of Newton's second law of motion.
Sir, can we define the force on the basis of rate of change of momentum?
Let's go for a long drive. Shall I drive the car? If you don't mind.
Yes, sir, we can go for long drive, but you have to explain me the relationship of force and rate of change of momentum.
While driving the car, we need to observe the two things. One is the mass of the car. Mass of the car does not change while driving the car, but the velocity of the car changes from one value to another value. Let us consider a car. In place of car, you can consider any other suitable object or desired object by you. But at present, to make you understand, I am considering a car. Let m equals to mass of the car. Suppose I got a car. The car is moving from point A to point B. And very first time, I observe the velocity of the car at the point A. Therefore, velocity of the car at the point A is called initial velocity. As soon as the car reaches the point B, the velocity of the car increases and car moves faster. So, the velocity of the car is changing at the point B. So, velocity of the car at the point B is called final velocity of the car. So, the velocity of the car at the point A is called initial velocity, and velocity of the car at the point B is called final velocity. Initial velocity of the car denoted by u and final velocity of the car denoted by v. Now car is moving from point A to the point B. So car is moving from point A to point B, and how much time does it take to go from A to B? Let us say car is going from point A to point B in time t seconds. T seconds. As car is moving in the forward direction, mass of the car is not changing, but momentum of the car is changing.
Sir, what do you understand by momentum?
Strength of motion acquired by a body is measured by something called momentum. Momentum is equals to product of mass of the body and velocity of moving body. Momentum equals to mass into velocity. Therefore, initial momentum of the car is equals to mass into velocity. Initial velocity was u, therefore initial momentum is mu, and the final momentum, the final velocity is v, therefore final momentum of the car is mv. So initial momentum is mu and the final momentum of the car equals to mv.
Sir, you said F equals to ma, where A stands for acceleration. Sir, how to find acceleration? Please give me a mathematical formula to find acceleration.
Rate of change of velocity is called acceleration, and it is given by mathematical expression vector A equals to vector v minus vector u upon t, that is rate of change of velocity. When you divide by time, it is called rate of change of velocity. So velocity change upon time, this is called rate of change of velocity. Thus acceleration is equals to rate of change of velocity.
Sir, I am having F equals to ma, and let us call it as a equation 1, and already you have defined acceleration a equals to v minus u upon t. Can I put the value of acceleration in equation 1, sir?
Yes, we can put the result of equation 2 in equation 1. Putting the value of equation 2 in equation 1, we get F equals to m into v minus u upon t. Here was the a. In place of a, I am putting this value. So opening the bracket, we get mv minus mu upon t.
But you said mv is a final momentum and mu equals to initial momentum of the object moving from one position to another position.
Yes, you are right. mv nothing but final momentum and mu equals to initial momentum. Therefore F equals to final momentum minus initial momentum upon t. T nothing but time.
Sir, here is the momentum is changing. So change in the momentum upon time, is it not the rate of change of momentum, sir?
Yes, change in the momentum upon time nothing but rate of change of momentum. Therefore, force equals to rate of change of momentum.
Sir, who discovered this formula?
Of course, it was given by Newton and it is called as a Newton's second law of motion. According to Newton's second law of motion, we can relate force and rate of change of momentum. That is, Newton's second law of motion gives relationship between the force and rate of change of momentum. Let us now define Newton's second law of motion, or let us decide what exactly the force is. Thus, force equals to product of mass and acceleration. Also, force equals to rate of change of momentum. On the basis of above discussion, we can define Newton's second law of motion as follows. Now, we can define the Newton's second law of motion. The rate of change of momentum is directly proportional to the impressed force, and change in the momentum of the body take place in the direction of the applied force. Thank you for watching my video and my presentation. I tried my level best to present the topic in a simple way. If you liked it, please share with your friends and subscribe my channel to motivate me to develop, to create better quality videos in coming future. Meet you again very soon with another video. Till then, bye bye, see you, meet you again with another video, with another topic on another day. Wish you good luck, all the best, bye bye.